Hello, I am Shubhakar Nayak, lecturer in Polymer Technology in Karnataka Government Polytechnic, Mangalore. On behalf of Department of Collegiate and Technical Education, I am going to present PPT on injection molding. It is my third session related to Unit 1. Course is Plastic Processing Technology. Program Polymer Technology. The course outcome is student will understand the basic knowledge of injection molding machine. Before I begin my today's session, just let us recap the previous session. We have come across what is called clamp mechanism. It is meant for holding the mold together whenever the molding is to be done. After the mold is filled, the material is injected, then again mold has to be opened. This opening and closing action of the mold, this is done by making use of clamp mechanism. There are different types of clamp mechanism. This we already we have come across. One of the type is hydraulic clamping. This is most commonly in most of the machines. And injection unit, what is it? What is the function of it? What are the various components of injection unit? We already come across in our previous session. In today's session, we are going to discuss about various topics like feed system, screw and barrel, check valve and nozzle, screw design, and orientation in injection molding and its effects. Now, let us discuss about the feed system. This is the most important part of the machine. The function of the mold feed system is to make high temperature melt under high pressure go into the mold cavity. The style and the quantity of gate and feed style often determine the specification of the mold. The feed system of the mold is a section of the melt flowing through the passage from nozzle of the injection molding machine to the cavity. It is divided into two main types, cold runner system and hot runner system. From the runner, there is at the tip of the runner there is a gate. It is called gate system. This gate system is a very narrow region through which molten material is allowed to pass into the actual cavity. To each runner, tip of the runner there will be gate, or sub runner if are there, then the tip of the sub runners this gate arrangement is provided. Now let me discuss about raw material handling equipment. Nowadays hopper loaders are available. We need not load the material manually. If the output is less and machine is of smaller capacity, then we can go for manual loading. Otherwise, in automatic machines, the melting capacity of course will be quite high and the capacity of the machine will be much more. Hence, manually we cannot charge the material. For this, we have hopper loaders. Along with this, dosing unit will be there, blending unit will be there, and also dehumidification of the material is done with the help of hot air. This hot air is supplied by the dryers, which are arranged at the bottom of the hopper. Material is conveyed through vacuum or pressure method from bulk storage, and there will be a sensor that will take care of the material, that will not allow the material to overflow. Up to the certain level, material is filled. Many times basic material is supplied to the machine through vacuum lines. Dosing and blending of color is done on individual machine. Dehumidification and preheating of the material is also done at the machine itself. Feed system. In this diagram, we can see the hopper loading arrangement. This is only for manual handling. The raw material is charged into the hopper by means of this platform. This is common in smaller version of machines. But if the machine capacity is higher, we can dump the material into the silo, and with the help of the vacuum pump, the material is charged into the feed hopper. So this material will be sucked because of the negative force or vacuum, and that will be dropped into the feed hopper. Here there is a sensor that will take care of the level of the material in the hopper. This is the end view of the machine, injection molding machine. Now let me discuss about screw arrangement. What is a screw? In injection molding, screw is a very important part of the machine. It is a solid shaft on which helical grooves are cut. This is like a propeller. The main function of the screw is to take the cold plastic material from the hopper, and it will be going to compact, help to plasticate the plastic material, and finally push out the material from the tip of the screw into the closed mouth. The screw is also functioning as a plunger and inject the plasticated material into the closed mold. Here in this diagram, you can see the screw geometry. This is the solid shaft on which this kind of threads are been designed. Through these flights of the screw, from the hopper end to the exit end, material will advance through this. This is placed inside a barrel, and this screw is made to revolve at a constant speed by a drive mechanism. So this is very important part of the injection molding machine. Now about the torque developed in screw and barrel arrangement. There are two basic torque setting available on the machine. In practice, it has been found that the high torque setting is rarely adjusted, and low torque setting would be adjusted only if a high liquid melt material is being molded, requiring high speeds of screw rotation. The Speed of the screw is also very important aspect. Screw rotation speed is related to the work input into the material. Higher speeds are applied only when insufficient heat is absorbed from the cylinder for a particular shot. Heat sensitive and shear rate insensitive materials do not tolerate high temperatures. Depth of the screw. The perpendicular distance from the top surface to the screw root is called depth of the screw. Flight. The empty space enclosed by one complete thread in a screw is its flight. Helix angle. Angle between the screw thread and the transverse plane of the screw is called helix angle. Usually, in injection molding machines, the screws have 17.7 degree as a helix angle. Lead. It is the horizontal distance traveled by the material in one complete revolution of the screw. Land. It is the surface of radial extremity of the thread of the screw. What is the pitch? Pitch of the screw. It is a horizontal distance between two consecutive points of the thread. Another important ratio is LD ratio. This is a key parameter in screw design. L stands for length, D stands for diameter. The length of the screw depends on number of sections being considered in screw. Here in this diagram, you can see a well-designed screw of this is of a injection molding machine. See, pitch is marked here from here to here, the center of the screw shaft to center of the screw shaft. This also is a pitch, or from the middle of this to the middle of the another thread here in between. This is called pitch. Depth is from tip to the root. This is called channel depth. Flight width is, this is called flight width, or it is also called land. This shaded portion is a barrel. This is a cross section of the barrel, and a screw is shown in this diagram. Now, what is a barrel? Barrel is a very important part of the injection molding machine. The function of a barrel is to melt the material with the help of the screw and heater arrangement. It is a cylindrical shaped one, usually placed horizontally, in which a screw or a plunger is placed. Together with the screw, it provides the bearing surface where shear is imparted to the plastic material. Usually, electrical band heaters are provided onto the screw barrel. Heating media, sometimes cooling media, are also housed around it to keep the barrel at desired temperature profile. The barrel size is specified by its inside diameter and overall length. Barrel length to diameter ratio is common practice to refer to the LD ratio. That is the ratio of barrel length to the diameter of the barrel. LD ratio is also known as length to diameter ratio. In defining LD ratio for a barrel, one may measure length either with the or without the feed opening. Thus, LD ratio is the distance from forward edge of the forward edge or from the rear edge of the feed opening to the end of the barrel. So, barrel length to diameter ratio, it is common practice to refer to the LD ratio, that is the ratio of barrel length to diameter. It is also often given for screws. In designing LD ratio for a barrel, one may measure L, that is length either with or without the feed opening. Thus, the LD is the distance from the forward edge or from the rear edge of the feed opening to the forward end of the barrel divided by barrel bore. The barrel of injection molding machine supports the reciprocating plasticizing screw. It is heated by the electrical heaters. The reciprocating screw is used to compress, melt, and convey the material. This diagram shows the barrel which is placed horizontally. In most of the machines, the barrel is placed horizontally and heaters are placed like this onto the barrel. These are circular band heaters. And the screw is placed inside the barrel as shown here, and feed hopper is here from which the material enters into the barrel, and this is the arrangement for rotating the screw, and this is the melted mass, and this is the mold in closed position. This is the movable platen and this is the stationary platen. This is the nozzle and screw arrangement for charging into the mold. Now let us go through what is a check valve. Check valve or non-return valve or reflux valve, retention valve or one-way valve is a valve that normally allows fluid to flow through it in only in one direction. This is the diagram shows the flow is in one direction. Check valve symbol is shown here on piping and instrumentation diagram. This symbol is usually we make use. Check valves are two-port valves, meaning they have two openings in the body, one for fluid to enter and other for fluid to leave. There are various types of check valves used in a wide variety of applications. This is a vertical check valve. So the body, here the spring, the valve disc is provided here, and with the help of the flange, this vertical check valve is fitted. Next, let me discuss about the nozzle arrangement. Nozzle is a device designed to control the direction or characteristic of a fluid flows as it exists an enclosed chamber or pipe. Is often a pipe or tube of varying cross-sectional area and can be used to direct or modify the flow of fluid. There are different types of nozzles are available. Standard nozzles, in most of the cases, for most of the material we make use, and some specially designed nozzles we make use for special type of raw materials. Nozzle is often a pipe or tube of varying cross-sectional area, can be used to direct or modify the flow of fluid. In nozzle, the velocity of the fluid increases at the expense of its radius. This is the how the material is pumped. You can see over here. So this kind of arrangement will be there in the nozzle. Types of nozzle. Two types of nozzles are generally available. General type of nozzles and nylon type. With the advent of screw type of injection machine, effective utilization of the melt decompresses feature and the drooling present with the general purpose nozzle, while molding nylons can be effectively controlled. This is because check ring shutoff system fits the barrel properly to produce effective suction at the point of nozzle outlet. This is the diagram of cross-section diagram of cut section of the nozzle check valve. The flow is from this direction. This will be going to flow like this. Here the one-way valve is provided. Orientation in injection molding and its effects. It refers to the alignment of polymer chains, whether they are stretched or not. Polymer chains have a preferred relaxed state. If they are not frozen stiff, they randomly coil up into the irregular shaped lump. When polymer melts, it pushed through runners, gate, and mold cavities. Shearing forces stretch molecular chains. This results in alignment of chains parallel to each other. This creates good strength in the direction of orientation. Stretching and weak strength in transverse direction takes place. The molecular orientation of polymer in the injection molding process changes the properties in the flow and transverse direction compared with non-oriented samples. Orientation leads to the following changes in the flow direction: higher tensile yield strength, higher tensile impact strength, increased shrinkage better crack resistance, improved environmental stress crack resistance, lower tensile elongation. Orientation leads to the following changes in the transverse direction: higher tensile elongation, comparatively lower tensile impact strength, reduced shrinkage, lower crack resistance, reduced environmental stress, crack resistance, the imbalance in properties that results from changing molecular orientation can significantly alter the performance of finished moldings. Now, we are at the end of this today's session. Let me discuss about some multiple choice questions and their answers. First question. Barrel is a hollow cylinder in which dash rotates. Answers are A. Ram, B. Screw, C. Mold, D. Clamping unit. Correct answer is a screw. Barrel is a hollow cylinder in which screw rotates. The ram will not rotate, ram will reciprocate. Here it is given rotates, screw rotates, not mold or clamping unit. Barrel is heated by the use of band heaters which are controlled for temperature. Answers are same, B. Different, C. Constant, D. None of these. In the barrel, we need to set different temperature. With the temperature same, of course, we will not be able to get a molten homogeneous melt. So different temperatures are required. In the entry zone, temperature must be low. Then in the middle zone, temperature must be maximum. And the exit end little lesser than the middle zone. The temperature should be set. So here answer to the second question is different temperature. Barrel is heated by use of band heaters which are controlled for different temperatures. Question number 3. Dash is a solid shaft on which helical groove is cut. Ram, screw, both A and B, any shape. Answer is a screw. Screw is a solid shaft on which helical groove is cut. Question number 4. Material of screw should be softer than that of dash because it is easy and economical to replace. Screw is a very costly part of the machine. So the screw finish, screw design, the LD ratio, the depth, land, all these are very important. Hence, we cannot replace the screw easily. That will be much costlier. And the barrel, of course, we can replace it because comparing to the screw, barrel is cheaper, easy to design and easy to dismantle, and all the way barrel is the most appropriate answer over here to the question number 4. Next question number 5. Dash zone receives the material from hopper and conveys to the next zone. Feed. Second answer is compression. Third is transition. D is metering. Feed zone receives the material from hopper and conveys to the next zone, not compression or transition or metering zone. Feed zone only receives the material from hopper. So answer A is correct one. Now, question number 6. The radius of the nozzle should be dash than the screw bush radius to ensure proper alignment. The radius of the nozzle should be smaller, bigger, equal, unequal. The correct answer to this question is smaller than screw bush radius. Question number 7. Mold cavity is fitted on dash. Mold cavity is fitted on mold. Cavity is fitted on, movable platen, fixed platen, any platen or mold. So, correct answer is fixed platen. Clamping system which contains levers is called dash clamping system. Toggle, hydraulic, tie bar less, and electric. The correct answer for this is toggle clamping system. The alignment of the chains dash to each other creates good strength in the direction of orientation. Chain parallel to each other creates a good strength, not perpendicular nor horizontal or inclined. So correct answer is parallel to each other, which will create good strength in direction of orientation. Thank you.